The storm worm is not a new one, but it is one of the smartest worms ever created. There have been 1 million identified infected computers, and studies have shown that infections could reach 50 million with unidentified infections.
You counted all those yourself, did you?
Well, I didn't. Somebody did. Storm dominated the internet by sending a huge amount of spam emails. 20% of spam emails are caused by Storm. And you can find a lot of information about Storm from www.schneier.com. But we're going to go ahead and just outline just a little bit of what's there for you. First, Storm is patient. Mm-hmm. A worm that attacks all the time is much easier to detect. A worm that attacks and then shuts off for a while and hides is much more complex.
And much more of a pain, too. Right? Yeah. And second, Storm is designed like, I don't know how to put it, an ant colony, really. It's got a separation of duties. Mm-hmm. Only a small fraction of infected hosts spread the worm. A much smaller fraction are C2, command and control servers. The rest stand by to receive orders, and by only allowing a small number of hosts to actually propagate the virus throughout the system and act as command and control servers, Storm is resilient against attack. Even if those hosts were to shut down, the network remains largely intact, and other hosts then can take over those duties.
That's right. And this is a big thing to keep in mind. Storm doesn't cause any damage or noticeable performance impact to the host. Like a parasite, it needs its host to be intact and healthy for its own survival. So this makes it harder to detect because users and network administrators won't notice any abnormal behavior most of the time.
That's right.
Now, rather than having all hosts communicate to like a central server or a set of servers, Storm, it propagated using peer-to-peer networks for C2. Now, this makes the Storm botnet much harder to disable. The most common way is to disable a botnet is to shut down the centralized control point. Storm doesn't have a centralized control point.
Yeah, so how are you going to do that?
And thus, it can't be shut down that way.
Right. Yeah, so, good idea, but it's really not going to work here. Now, this technique has other advantages. Companies that monitor net activity can detect traffic anomalies with a centralized C2 point, but distributed C2 doesn't show up as a spike. It's hard to read. Yeah. Communications are much harder to detect. Now, one standard method of tracking root C2 servers is to put an infected host through a memory debugger and then figure out where its orders are coming from. Gives us at least a step down the road. Now, this won't work with Storm, however. An infected host may only know about a small fraction of infected hosts, 25 to 30 at a time, and those hosts are an unknown number of hops away from the primary C2 servers. Very hard to read.
That's right. And even if a C2 node is taken down, the system doesn't suffer. So like a Hydra with many heads, Storm C2 structure is disrupted. Not only are the C2 servers disrupted, but they also hide behind a constantly changing DNS technology called FastFlux. So even if a compromised host is isolated and debugged, and a C2 server identified through the cloud, by that time, it may no longer be active.
That's very true.
Storm's payload, the code it uses to spread, morphs every 30 minutes or so, roughly, making typical antivirus and IDS technologies less effective, in my opinion.
Yeah, no, it's changing too much. They can't really hone in on it, right? And Storm's delivery mechanism also changes regularly as well, making it even harder. Storm started out as a PDF spam, if you remember, and then its programmers started using e-cards and YouTube invites, things that people use every single day, anything to entice users to click on a phony link. Storm also started posting blog comment spam, which, of course, we can't not keep our hands off of, right? Again, trying to trick viewers into clicking infected links. And while these sorts of things are pretty standard worm tactics, it does highlight how Storm is constantly shifting like a worm at all levels.
Storm was my favorite X-Men character, too.
Yeah.
Storm also sends emails, and they're changing all the time, leveraging social engineering techniques. There are always new subject lines, new enticing texting, like a killer at 11, he's free at 21, and so on and so forth. Football tracking program on an NFL opening
Fantasy
weekend.
Football gets you every time.
And major storm and hurricane warnings. Storm's programmers they're very good at preying on our human nature. Storm began attacking anti-spam sites focused on identifying it spamhaus.org, 419 Eater, and so on, and the personal website of Joe Stewart, who really published analysis of Storm. Now, I'm reminded of a basic theory of war. Take out your enemy's reconnaissance.
Mm-hmm.
Or a basic theory of urban gangs and some governments. Make sure others know not to mess with you.
It's a good one, too. Yeah. All right, let's talk a little history. On July 12, 2001, a worm started spreading. It targeted Microsoft IIS 2000 servers. The worm, Code Red version 1, used specific dates to activate. From the 1st till 19th of the month, it spreads itself on the network searching for vulnerable servers. From the 20th to the 28th of every month, it does something different. It launches a DOS attack against www.whitehouse.gov. The infected machines, IIS, were defaced by a web page that had been written on it, hacked by Chinese. Like that. CRV1 had a little damage, and it was a memory resident code that reactivates with every boot of the server. CRV1 used BOF, buffer overflow, vulnerability in ISS 2002 targeting ISAPI.IDA. Now we can see here how smart this code is as it targets BOF or BOF vulnerability to implement a worm that defaces the website and ships a bot code to initiate DOS attack. Crazy, huh?
It's crazy. Then, not only that, but on July 19th, a new variant of Code Red, CRV2, was released with a minor change. CRV1 used static seed in generating the list of a probed IP addresses to be the next target, and was always targeting the same IP addresses.
That's right.
CRV2,
No.
It had this changed. It created a random seed instead of a static. So each infected computer tries to infect a different random list of IP addresses. This minor change had a major impact of CR. Now, only 14 hours, it's believed that nearly 400,000 computers were infected.
But wait, there's more.
Oh my gosh.
On August 4th of the same year, Code Red 2 was launched. You remember that? It wasn't a new version. Rather, it was a completely new worm. ASO targeting ISS 2000 and installing a backdoor. It did not deface any website or attack the White House this time. However, the backdoor allowed remote root level access. Now, of course, the backdoor could be used to initiate DOS or DDoS attacks in the future. Another difference, Code Red 2 was not a memory resident worm. So rebooting the machine had absolutely no effect at all on the worm.
It was crazy.
It's got getting worse and worse.
Well, they got smart. Why would you attack the government? It's crazy. Let's talk about Stuxnet. Remember that one?
Oh, yeah. Are you kidding?
So discovered in 2010, and although it's believed really that it was first programmed in 2005 and then used to attack Iran's nuclear program in 2007, it's designed to attack industrial PLCs that allow the automation of electromechanical processes, such as those used on mechanical factory assembly lines, amusement rides, or centrifuges for separating nuclear material.
Right.
Now, Stuxnet exploited 4 zero-day flaws on Microsoft Windows, and then it targeted Siemens Step 7 software on those machines.
Yeah.
Stuxnet's design and architecture are really not domain specific, and it could be tailored or as a platform for attacking modern SCADA and PLC systems.
Yeah, and you probably wonder what a worm like that can do to huge machinery. I mean, the idea of amusement rides? Come on. I mean, that's...
Seriously.
Yeah, or even nuclear plants, like you mentioned. But intercepting the command sent by the operator, the user controlling the system, what it does is it modifies the code and sends unexpected codes to the PLC while it returns a loop of normal operation system values to the operator. And these modified codes then can cause very fast-spinning centrifuges to tear themselves apart. And that's just horrible to think about.
Not good.
Yeah, so Stuxnet looks for Step 7 programs in PLC. If none are found, the worm stays dormant. If any are found, it starts, massive destruction. Right. And so it is the first discovered malware that spies on and subverts industrial systems. It lays in wait, and the first to include a programmable logic controller, PLC, rootkit, to hide its files. We've seen nothing like it.
No. Conficker targets Microsoft Windows Server Service, RPC, handling remote code execution vulnerability, which was really discovered in late October 2008. Now, the worm was detected in November of the same year, and it has the ability to update itself or receive additional files for execution. Now, it does this by generating large numbers of domains to connect to every day. Now, the worm may also receive and execute files through a peer-to-peer mechanism by communicating with other compromised computers, which are then seeded into the botnet by the malware author. Now, Conficker did not need any reprogramming or new versions. It had the capability to update its code remotely.
Yeah, and that's another scary side of what these viruses are able to do. The worm blocks access to predetermined security-related websites so that it appears that the network request timed out, which happens all the time, right? It's nothing. It's not really a red flag. And furthermore, it deletes registry entries to disable certain security-related software. It prevents access to safe mode, disables Windows security alert notification, just silently just breaks down your defenses until there's nothing left. Nearly 3 million computers. 3 million computers were infected by this worm. And with this huge number of bots, no one knows why it was not used to launch any DDoS attacks, too. I guess maybe
it's a good thing, though.
we averted that problem.
Yeah.